Let's see the different interpretation and different meaning of this conditional operator or implication operator. P implies Q. So there are different meanings. One is if P then Q. So the meaning of this if P then Q can be shown by P implies Q. Similarly, its direct meaning P implies Q. If P then Q. Few other. If P comma Q. Q whenever P. So whenever P is true, Q is true. Or Q follows from P. Q if P. Q when P. And few interesting interpretation, P is sufficient for Q. If P is true, Q has to be true. So we can say P is sufficient to Q. This is little bit tricky. Q is necessary for P or P only if Q. These two meanings are identical. P is true only if Q is true. So means Q is necessary for P. So let's understand this by taking some example. Apart from this, one more meaning is Q unless negation P, which means if negation P is false, then Q must be true. Once again, if negation P is false, then Q must be true. That is, if negation P is false means P is true. If P is true, then Q must be true. So if P true, then Q true is nothing but if P then Q. So this interprets the same meaning of P implies Q. Now let's see this P only if Q. This statement or Q is necessary for P. So let's take an example of today's date. Today is 25th December 2020, Christmas, and this is the today's date. This is day. Day is Friday. So the statement today is 25th December 2020. Let's represent it by P, and today is Friday. Let's represent it by Q. So P means today is 25th of December 2020 and Q means today is Friday. So if today is 25th December 2020, then today is Friday. This is clearly true. On 25th December 2020, there is Friday. So if this statement is true, this is also true. So whenever you will see this date in calendar, you will always get Friday. So P implies Q is fine. Now let's see P only if Q. From this we can also prove that P is sufficient for Q. P is sufficient for Q. So the date 25th December 2020 is sufficient to be Friday. Now P only if Q. So today will be 25th December 2020 only if today is Friday. If today is not Friday, then there is no chance we can have 25th December 2020. It doesn't mean that if today is Friday, then today is 25th December 2020. But this is necessary. This will not be sufficient. However, this Friday condition is necessary for the today's date of 25th December 2020. If you see a calendar and on that day it is Friday, then there is a chance that today may be 20th December 20 or today may not be 25th December. But if today is not Friday, it is like Thursday or Sunday, then there is no chance that it can be a 25th December 2020 date. So only if Q is true, then we can have P, or in other words, Q is necessary for P. Q is necessary for P. There are other mathematical approach also which will prove this, but this one is a real life example through which we can understand it easily. So question is, by truth table show that negation of P and Q and negation of P or negation of Q are logically equivalent. So let's first create their truth table. PQ, 4 possible combination, true, 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 false, false, true, false, false. What will be negation of P and Q? First, P and Q is true, its negation will be false. Here P and Q is false, negation is true. Same case with the rest. And if we find negation of P, disjunction negation of Q, so false or false is false, false or true is true, true or false is true, true or true is true. So these two columns are identical. If two columns are identical, these two, then if we perform their biconditional, like let's call it column number 2, let's call it column number 3. So 2 biconditional 3, this is going to be true in all cases, because false biconditional false is true, true biconditional true is true. So now this 2 biconditional 3 is a tautology, hence we can say they both are logically equivalent, as the definition of equivalent is this. This is equivalent to this if left hand side biconditional, right hand side is a tautology. So here we are getting it as tautology. So hence these two are logically equivalent. Let's verify next. Use truth table to verify. And one more thing, and this was nothing but one De Morgan's law. So whenever negation is there outside a braces, when we open it, and is changed into or, and this negation is placed or it is moved inside every proposition. So next, use truth table to verify P and true as P and P is equivalent to P. So it is not difficult. Let's say P, the two possible combination, either it can be true or false. Let's perform and with T. So what will be P and T? True and true is true, false and true is false. So this is exactly same as P. So if we perform P biconditional T and true, it has to be a tautology because both are same. Hence we can say P is logically equivalent to P and true. Similarly we can find out P and P. Since both P and P will be same, so this P and this P, again they are going to give you a tautology. Hence we can say this is equivalent to this. So let's verify this also. Second expression, P, once again write P, now write P and P. True, true, false, false. So it can only take true or false, same case here. So true and true is true, false and false is false. Now this is exactly same as any of these P. So if we perform P biconditional P and P, we are going to get true, true. So it is a tautology. If this and this is a tautology, both are equivalent. So hence it is also verified. Similarly, we can verify P or P as P, because true or true will be true, false or false will be false. So again the result P or P will come out to be same as P, hence their biconditional will be tautology. So this is one thing that we can prove equivalence, and the difference between this equivalence, which is similar to this, and this biconditional.